On a frictionless surface, a block of mass m, so this is mass m, moving at speed v, collides elastically with another block of mass same mass m, which is initially at rest, and it is at rest, and the collision is elastic. So when same mass, okay, and the collision is elastic, okay, so what happens is the velocity gets exchanged. Okay, now this is not a complete statement. It gets exchanged along the line of impact. Okay. So mind you, it's along the line of impact. Okay. Now here it's not said that they are going to strike head on. The word head on is not used. Okay, so velocity will get exchanged, but it will be along the line of impact, and since it is not head-on collision, so we cannot do like this. It starts going with v and this becomes 0. No, that's wrong. Okay, so how to solve this? So after collision, the first block moves at an angle theta to its initial direction and has a speed v by 3. Okay, so after the collision, it is moving with v by 3 at an angle theta to its initial direction. Okay, the second block's speed after the collision is, so let us say this is having a velocity vx in this direction and vy in this direction. So we do the conservation of momentum in both the directions. So first let us do in x direction. So m into v, that's the initial momentum, should be equal to m into v by 3 cos theta plus m into vx. Gone. So therefore vx is equal to v minus v by 3 cos theta. That's the first. Second thing, in y direction, so we have m v by 3 sin theta plus m vy. Okay, so v by 3 sin theta, this is the component in this direction. So this is the momentum in y direction for the first mass. Initially the momentum in y direction was 0 for both of them. Okay, so this is equal to 0 plus mv y. Okay, the momentum in y direction for the second mass. So therefore vy is equal to minus v by 3 sin theta. Now the second block's speed after the collision. So they are talking about speed, so we have to do root over. Okay, so let us do this. So root over vx square plus vy square. So this is going to be v square plus v square by 9 cos square theta and minus 2v square by 3 cos theta plus v square by 9 sin square theta, which is equal to root over v square plus v square by 9 minus 2v square by 3 cos of theta. Okay, now one thing which has to be understood here is, you see, Now we are getting in this in terms of cos theta. Now the velocity will get exchanged along the line of impact. Okay, so along the line of impact the velocity is getting exchanged, and it's elastic collision. So in the collision which is elastic, we will also have the conservation of energy. Therefore, now if you see, now this one is becoming complex, and now we have to find cos theta and all. So therefore we have to just find, like, because it's elastic, so no energy will be lost. Okay, so by conservation of momentum also we'll get the answer. Okay, however, we have to see that the shorter version will be the conservation of energy. Okay, so like I'm not going to delete this thing. Okay, when we did the conservation of momentum, things are becoming complex now. Little bit if we think, then no energy is lost, so therefore the kinetic energy initial will be equal to the kinetic energy final. So therefore half m v square should be equal to half into m v square by 9, which is v by 3 whole square, plus half m, the final velocity square. Gone and gone. So v final square, which will be 8 by 9 v square. So v final will be equal to 2 root 2 by 3 into v. So therefore D is going to be the answer. Now here, if we want to solve it in terms of this, then we have to consider. Okay, so now we have to solve for cos theta. Okay, and it is elastically. Okay, so so now this is V, this is at rest. Okay, and now this is going by, so this is A, B, and now this A starts going with velocity v by 3 at an angle theta. Okay, so that means in this direction. Okay, so since the velocity is going to get exchanged, so A will retain its velocity, which is parallel to the line of impact. So therefore the line of impact is this. Okay, so since this is V, so V cos theta is equal to V by 3. Okay, and now this V sin theta will be getting exchanged here. So this has started now traveling with V sin theta. So V cos theta is V by 3. Now we substitute here. So this becomes V square plus, so this was root over V square plus V square by 9 minus 2V square by 3 cos theta minus 2V square by 3 cos theta, and cos theta is 1 by 3. So 1 by 3, so 2 by 9. So therefore root over V square plus V square by 9 minus 2V square by 9, which is equal to root over V square minus V square by 9, which is root over 8 by root over 9 V, which is again 2 root 2 by 3 V. So that is the D option. Thank you.